Hello and welcome to our video solution for problem 2 from Superquiz 2. So here's a little divisibility question. We're given two integers, a and b, no restrictions, just any two integers, and we're assuming that a divides b and that b divides a, and we want to show that in this case a either equals b or a is equal to negative b. So this really just comes down to figuring out, okay, what's the definition of divisibility? So what does it mean that a divides b? So for a to divide b, this means that there exists an integer, well, how about we'll call it s, so an integer s such that b is equal to a times s. Okay, well we also know that b divides a. What does that mean? Well, it means there exists an integer, and this is where maybe people run into trouble. If they use the same name for the integer here, that's going to be a problem. All right, that's not really what's meant here, right? You need to have, generally speaking, different integers. Even if they ultimately could be the same, you need to call them something different because there's no a priori expectation that they'll be the same. So there exists some integer t such that a is equal to b times t. Okay, now what we want to do is combine these two equations, and hopefully we'll get something about s and t, like maybe they're both 1 or they're both minus 1. So let's try something. Therefore, a is equal to b times t is equal to, well, we know what b is. B is equal to a times s. Okay, of course I have associativity here, and so I could write this as a times st. Now, what a lot of us are tempted to do at this point is to divide by a. Don't divide by a. Okay, why not? Well, let me put this in parentheses so you don't think I'm talking about a factorial. Why not divide by a? Well, a could be 0, right? I didn't assume that a wasn't 0. So I don't want to separate that out as a special case. So it's a really useful thing to not divide and to learn not to divide when you are tempted to. Instead, it's actually usually better to subtract. So subtracting gives, okay, so I'm just going to say I'll subtract the a to the other side. So I'll have 0 equals a times st minus a. And I can now factor out an a from there. And I'll have a times st minus 1 is equal to 0. And now this is what's sometimes called the zero divisor property of the integers. We know that when you have a product equal to 0, one of the factors must be 0. So thus, a equals 0, or st minus 1 is 0, which would mean that st is equal to 1. Now, at this point, right, we now know, okay, a could be 0. Let's see what that means. So if a is equal to 0, then what does b equal? Well, b was equal to a times s, but a is 0. So b is also going to equal 0, in which case a and b are definitely equal to each other. All right, so when a is 0, we actually do get some sort of a solution, and it matches what we claimed. Okay, so what about if st is equal to 1? Well, s and t were both integers, and there's not so many integers that can multiply with each other to give you 1. In fact, there's only 2 sets. So then, since s and t are integers, s and t are both 1, or s and t are both negative 1. Right? It's the only way to do it. Okay, so what if s and t are both 1? Well, if s equals 1 equals t, then what was a? A was equal to b times t, or b times t. Well, t is 1, so a is equal to b. What if s and t are both -1. Well, then a is equal to, well, still b times t, but now t is -1, you get -b. So in either case, we're going to get a equals b or a equals -b. And that's what was required.